Hi, welcome to another lecture in the Cosmos Redshift. Previously, we have discussed about the vectors, the definition of the vectors, the idea of the vectors. We have also seen how to calculate the vector. Calculate means how to addition, doing the vector addition and the subtraction. And also we have seen the vector multiplication as well. The multiplications does means that scalar multiplication or the dot product and the vector multiplication or the cross product. We also even see the complex method of the triple product and the Levi-Civita symbols as well. From here till now we have discussed mostly about the vectors algebra and the vector geometry, but from there we are going to dive into the vector calculus as well. But before we doing the vector calculus and starting the rigorous mathematical stuffs, let's first build our physical intuitions about this. So let's start with the idea of the field. What is field? You must have heard this word many times before. The field, in when you are studies the gravitation, you have heard about the gravitational field, you have heard about the electric field. But what is the field? Field is a physical quantity that assigns a value specific single every single point in the space. So so in your room every point has different temperature, so it is our this is our called field. Okay, now field, we can see two types of field here. One is scalar field, like the temperature, what I have given an example already. The temperature, if you see in your room, that what you can see, you can see that if you take your hand toward near the windows, and if you take your this same hand toward near the microwave or the fridge or near the some computers, you can feel the difference in temperature in the different places in your same room. So that does mean in your the same room the temperature is not same everywhere. Every single point does have different temperature. This kind of field are called scalar field. Except the temperature, you can see the atmospheric pressure. If you see in your entire state, the different place has different atmospheric pressure. So these are the scalar field. These are the only number in every point has just some different number, not anything else than number. But another kind of field we can see is called vector field. What is vector field? If you see in every point, you see a river, or if you see a cyclone and wind map, so every point does assign some numbers, but not only a numbers, it's also every point assigns some direction as well. Only magnitude is not enough to describe the motion of the river. So this kind of field are called the vector field. Now what if you moving through a into the vector field, right? What, suppose if you are in a inside the temperature field, temperature distribution, that we can write it as a function of like t. It is a function here x, y, z. Okay, now this function is called a scalar function. You are inside this function. Now if you change a little bit of your displacement here, little bit means very small change of your displacement, that is called infinitesimal step, and we can write this vector as a dr. Dr is a very small space, so very small change in x axis, y axis and z axis will gives you this displacement vector very simply. Now how much this change with that small displacement vector, it is our the change is we can think of that change with this partial differential equations. Okay, now what is the first component is this dt dx, that does means the rate of change along with that x-axis. So how much temperature change with if you go along that x-axis, and that dx does means that how much you have literally moved in this axis dx. Okay, now these equations can be rewritten as some fancy form d of dx ex plus d of dy uy plus del of del z ez. Okay, that temperature this. But that is not complete. We have dx dy dz. So when we have dx dy dz, if we do a dot product with of this, okay, now dx ex plus dy uy plus dz ez. Okay, now if you see, this is your that infinitesimal change of that vector actually. So this is dr, and if you see these things, we can write this into the del. We tell is this del, or this is a gradient, and this is our r. Okay, dr, actually there's very small change in this. So the change of temperature will be like this, the gradient of this, and with this multiply with that dr. Okay, this is the dot product, actually dot product of the gradient and the dr. That is the change of the temperature, how little change of the temperature. Now if you see that any force are the source from that point, from the central source to outward, that force is working, we can from the Pythagorean law we can find that radial distance r is equal to x square y plus y square plus z square of the root of that things. So we can find that r square, that is x square plus y square plus z square. Okay, now we can find the gradient of this r. How we can find the gradient of this r? First is that r square is equal to, we can write that x square plus y square plus z square. Now if we do the derivative of this r square, one interesting thing we will see that dr dx is equal to x by r. This is okay. Now if you find that gradient of this, what will we see? The gradient of that will be del of del x ex plus del of del y uy plus del of del z ez. Okay, into this r. Right, now del of del x del these are the thing. So for every point we will see that what is that dr dx plus dr dy plus dr dz along that x component unit vector along with the uy unit vector and ez unit vector. Right, now dr dx, what you get that from that dr dx you can see x by r. So x by r e cap so you can see that x by r ex cap plus y by r ey plus z by r ez. Now if you see that x ex plus y ey plus z ez, that is your the vector r. So the finally if you find the gradient of that, you will see that vector r by r, that is called our unit vector pointing outward. Right, now we have find that del r there. Now here we have to find del r to the power n. How we will find del r to the power n? Same way you can find that del r n del x, that will be n r n 1 minus del r del x. Okay, now if you finding that what will be the del r del n, so this will be del of del x r to the power n ex plus, in that way it will be goes on. Right, now that now if you think take the common, so plus uy will be there and the z will be there, and if you take that things common, then you will see that n r to the power n minus 1, and inside the what will be there, dr dx, along with that ex cap, actually ex cap plus del r del y uy cap plus del r del z ez cap, right? Now the finally you can see that again you that n into r n minus 1, that will into that unit vector. We have seen that this is give you the unit dr dx will be x by r. So you'll find again that gradient of r to the power n will be n into r into n minus 1, along with that unit vector will be along with that r. Okay, now Coulomb's law. Now what Coulomb's law says is that for potential we get a force, right? Force. Now potential is our scalar field and force is our vector field. Now now it is proportional. We can see that the potential of electric field is the proportional to the 1 by r. So the what is the force field is minus of the divergent of 1 by r, because that is our potential, and the gradient of this will gives you the force. Like the same way, you can say that in your room different position of the, if you think of a state, the different place of your state have different atmospheric pressure. So it does the scalar things, but for the different atmospheric pressure somewhere the cyclones will be there. So for that scalar field they are creating a vector field, and the reason of creation of this from the scalar field to vector field is the gradient. Now you can ask that why the minus? The minus is because in which direction the your field is, actually the force will act on the opposite direction, so there is minuses for that. Now we have seen that 1 by r, gradient of 1 by r. Now we can find the gradient of r 1 by r. What is 1 by r? The 1 by r can be written as r to the power minus 1. Okay, now if you using r to the power n gradient of rules, so you can see that minus of minus n to the power r minus n minus 1 of the grad r, and this grad r means the unit vector along the r axis. Okay, and this is r to the power minus 2 1 by so the force we get is 1 by r square along with the r unit vector r. You can see, if you can see the gravitational force or the electrical force, all the force are look like similarly this type of things. There might be different component as well, but this is a if we are talking about only the r component, it will look like this. Okay, so what we have seen, that if you have a scalar things, then that scalar will be and if you use some gradient things, it will give you the vector field. Okay, like atmospheric pressure, you have atmospheric pressure, you applied some gradient, you will see some cyclone there. Thank you so much. If you need our study material, you can visit our website. We will put our link of the website below this in the description box. Thank you so much.
वीडियोस बनाने हैं, फिल्मोरा है ना।